technology advances in the search for hydrocarbons in deep water, so has the technology for interconnecting subsea pipeline systems. Until recently, major oil companies have relied on expensive lay barges to construct and position pipeline systems. However, the advanced technology of onshore pipeline bundling, developed by Kverner R.J. Brown, has proven to be a cost-effective alternative. So what exactly is a pipeline bundle? Simply stated, a bundle is a group of product flow lines and hydraulic and electrical control lines, all of which are contained within a watertight carrier pipe with diverless connection systems or sleds on each end. Depending on the application and water depths, these bundles can reach up to 15 miles in length, using a single towing vessel for installation, and can be designed to withstand the crushing pressures at depths to 6,000 feet. Typically, a bundle consists of the outer carrier pipe or casing, internal product flow lines, a hydraulic and electrical line umbilical, and supports on rollers or spacers. Also, to reduce the risk of hydrate formation in deep water flow lines, open-cell polyurethane foam is used for thermal insulation. Heating lines for warming the bundle system can be added if required. Pontoons can also be added near the sled ends for additional buoyancy during deflection. Depending on the application, sleds are attached at both ends of the bundle, with a variety of end connector systems. Although a bundle can be assembled and launched perpendicular to the shore, the parallel method is attractive where long beaches are present, such as along the Texas Gulf coastline. The entire bundle is made up in one piece and launched laterally into the sea. This permits full assembly, testing, and maintaining the launching window to a minimum length of time. Assembly begins by making up the flow lines in approximately 4,000-foot sections, each of which is pressure tested. Next, the entire length of the outer carrier pipe is made up, pigged, and hydrostatically tested. The flow line sections are then bundled together and placed within roller support assemblies, including the hydraulic control umbilical. As the flow line bundle is pulled into the carrier pipe by a winch cable from the far end, preformed open cell insulation is placed around the flow lines and banded together. This process continues until the entire length of the flow line bundle has been completed. The leading and trailing sleds are then joined and tied in to the completed bundle, and a system integration test is performed. After the successful test, the bundle and end sleds are then cradled over to the sea with tractors and placed as far as possible into the surf. The interior of the carrier pipe is pressurized with nitrogen to counteract hydrostatic pressure on the casing at great water depths. The nitrogen fill also provides an environment to prevent corrosion of the carrier pipe's inner wall and the interior components. A tow line is passed from the tow vessel to the shore and is connected to the front sled. While firmly anchored, the tow vessel begins to winch in the tow cable, beginning the lateral deflection of the bundle off of the beach. During the deflection, survey instruments on shore track the lead sled, confirming that it is moving within an acceptable deflection envelope. This entire lateral deflection sequence is developed at Kverner R.J. Brown's modeling facilities in Houston, Texas. Once underway, the tow vessel follows a predetermined course to avoid pipelines, submerged obstacles, and environmentally sensitive areas. With the bundle in tow, a second vessel with survey and ROV capabilities follows and monitors the lead sled, tracking its horizontal and vertical position. This information is continuously transmitted to the tow vessel. For the final tow-in of the bundle near the installation site, a detailed analysis of the relationship between the tow vessel, sled, and bundle touchdown position is prepared by Kverner R.J. Brown engineers. This is required to accurately place the leading and trailing sleds in their predetermined targets. After tow-in, each end of the bundle is deflected within a predetermined deflection envelope to their respective receivers, and final connections are made to subsea templates or platforms. The bundle is then completely tested and commissioned for operation. The technology of designing, fabricating, and towing bundled pipelines has advanced considerably over the past decade. Because of their excellent track record, major oil companies are now turning to Kverner R.J. Brown for their deepwater pipeline and flowline needs. Kverner R.J. Brown's recent experience with pipeline bundles include the 1986 installation of 10, 8, 7, and 2-mile bundles for the Placid Green Canyon Block 29 development in a maximum water depth of 2,400 feet. 1992, 3 and 6-mile bundles were installed in Ensearch Exploration's Mississippi Canyon Block 441 development in a maximum depth of 1,550 feet. In 1995, a 4-mile bundle was installed in 1,000 feet of water for Flex Trend Development Company's Garden Banks 117 project. And in 1996, a 3-mile-long bundle was installed in 2,100 feet of water at Garden Banks 387 for Ensearch Exploration. Some of the advantages of the bundle flowline system as opposed to the single-line installation with lay barges include reduced costs by eliminating expensive offshore equipment requirements, insulation capabilities and heat loss control, reliability in connection arrangement, pre-testing of the complete system onshore, extra physical protection provided by the casing pipe, no cluttered and crossed flow lines and umbilical cables. The engineering firm of Kverner R.J. Brown pioneered the development of complex flow line bundling, successfully installing the first diverless tie-in for Panarctic in the Canadian High Arctic region. Kverner R.J. Brown is the world leader in deepwater bundling technology with the knowledge and experience to successfully design, fabricate, and install bundled flowline systems in greater ocean depths. Kverner R.J. Brown is now a member of the Kverner Group of companies, one of Norway's leading companies with over 24,000 employees worldwide. Activities encompass shipbuilding, pulping, and engineering, as well as major involvement in the oil and gas sectors. Kverner R.J. Brown, finding a better way through innovative engineering.